Okay.
Uh, let's start the
Uh,
session.
let's start
My
the
name is
session.
Satyakam
My
Pratap
name
Singh
is
and
Satyakam Pratap
I
Singh,
am
and
PMRF
I am
TA of
PMRF
your
TA of
this
your
Smart Grid Basic to
this
Advanced
Smart Grid
Technologies
Basic to Advanced
course,
Technologies
and
course,
whose instructors are
and whose
Professor NP
instructors are
Pardesa and
Professor
Professor
N.P. Pardesa and
Premlata
Professor
Jana ma'am. This
Premlata
is
Jana
your
ma'am.
fourth
This is
tutorial
your
session,
fourth tutorial
and
session,
last
and
class we have discussed
last
this
class we have discussed this
energy storage systems
energy
and
storage
their
systems
applications in the
and their
smart grid.
applications in the smart
And
grid.
in the last class,
And in the last class,
the BMS part is
the
I
BMS
thought
part
it
is
is
I
little
thought
touched.
it is
So
little touched.
I
So
am
I am
explaining
explaining
you
you
more
more
about this
about this
BMS system
BMS
and
system and
SOC and
SOC
SOS
and
system.
SOS
It is
system.
also
It is also
a
a
booming topic
booming
right now.
topic right now.
The how
The
to
how
measure
to measure
correctly
correctly
measure
measure
this
this
SOC and
SOC and
SOS
SOH
kind
kind
of
of system.
system.
After
After
that, we
that,
will
we will
move to
move
this
to this
your
your
fourth
fourth
assignment
assignment
related
related
topics.
topics.
Okay.
Okay.
So,
If
if
you
you
have
have
any
any
doubt
doubt
in
in
between
between
of
of
the
the
lectures,
lectures,
please
please
open
open
your
your
mic
mic
and
and
ask
ask
me,
me,
or
or
you
you
can
can
write
write
in
in
the
the
chat
chat box
box.
also. Okay.
That
That
my
my
screen
screen
is
is
visible
visible
to
to
you.
your. My screen is visible to all.
If
If
anyone
anyone
can
can
confirm.
confirm.
Blur.
Blur. Blur.
Blur.
I think this is not
This is
useful
not
from
useful
my
from my
side.
side. If anybody
If
is also
anybody
facing
also
this
facing
issue,
this issue, this blur image,
blurred
blurred
slides.
slides or anything.
Shoma,
Shoma,
can you
can you
please
please
confirm?
confirm? Screen is blur
Blur
from
from
if anybody
if
can
anybody can
confirm that.
confirm.
Okay, Surya Prabhu is saying is okay. Ritika, please zoom
Zoom
this
this
image.
image, you
You
can
can get
get
that
clarity
clarity
of
of the
the
image. And if you have any thought in between, you can message in the chat box also. This screen is blur or anything. I will zoom it for clarity purpose. Okay, let's move to the first slide. That is the BMS system. I last class I have explained this what is the BMS system, the IEEE standard and their actually definition of this BMS. Let's jump to the what are the components inside this BMS. If you see in I have given one this image for your understanding. This if you see that this BMS have certain section. First section is battery state estimation section, that is the SOC, SOH, and state of function, whether the pre-required desired thing is happening as according to your desired thing or not. This is the state of function of the particular sections. And in the right side you can see the advanced user feature, that is the prediction models or anything. What do you mean by this predictions or models? Suppose you have this SOH. SOH means the state of health of the battery. The state of health of the battery. If you have this, let's say that you have purchased a new battery and that SOH, that 100% is there, and this capacity will reduce when you use it for the number of cycles, then this SOH will reduce. So this predictor based mechanism say that up to what time this SOH will function fine or not. Suppose the 100% to 80% if it goes, then you can discard this battery. So this 80% when it will be there after 2 years, after 3 years, this prediction based mechanism gives you this amount of this exam, this facility. Okay. This safe operating area is that there is a certain amount of temperature, voltage, and current ranges are there for this equipment. So there is a safety guards are there, which have this temperature range in which it can operate, voltage range, current ranges are there. So you have to operate in that fashion that it should not limit this current range, voltage range, or temperature range to maintain this battery pack at a optimal level, function at a optimal level. And certain databases are there. Databases in what sense? Suppose you have got a fault or your cell voltage have exceeded its limit, so you can get the data that when that happened and what kind of mechanism was responsible for this overcharge, over discharge, whether it is a human error or any software related issue. So from the database you can predict, or we can observe that from where this problem is coming. Next is the cell temperature. Cell temperature is basically this database also, that whether the temperature is optimal level or not, and whether the your cooling mechanism is working properly or not, when it maloperated. That kind of battery current, battery control, balancing feedback, IO request. IO request in the what sense? Suppose I am taking example of the EV. If you see this, how you charge this EV? EV have certain onboard or offboard chargers, onboard or offboard chargers. So and EV have this battery and with BMS is there. So this onboard charger give a request to this BMS to send the power to this charging the battery. Then BMS acknowledge that part with giving a certain request to this offboard and onboard charger to get the power for charging the battery. So this is the IO request is also there in the database. So what kind of IO request is responsible for this charging? And self-diagnostic, if you see this self-diagnostic, the self-test whether this properly the software you have installed is correctly measuring or not. If it is able to locate the fault, self-diagnosis the things or not. It have a certain parts such as the power on self test, power on monitor, watchdog, error handling, integrity check, contactor feedback. And the next side is the certain storage system. Storage system is that electrically programmable random read only memory or random SD ROM. So this kind of memory based system is also there for the data storage. Okay. In the next system, you will see this contactor control, thermal control, interlock control. These things we will discuss further in the coming slides, whether what kind of this thermal control and contactor controls are there. And there are one more interface drivers are there, that is cell monitoring ICs. Cell monitoring ICs, that suppose you have two cells connected in series. So each cell monitors will be connected in, suppose the voltage sensor is connected in parallel with this battery, and another voltage sensor is connected to this another battery. So this cell monitoring means voltage monitoring. If you connect the this ammeter also, this current sensor in between, so that measures the voltage and current of this battery and safeguard this battery whether this is overcharging or going beyond this voltage limit or anything. So it will correctly switch off that system. So if it is in suppose there are certain modes of charging, there is CC/CV mode. So if it reaches the CV mode with the 100% or 80% SOC, so you can switch off this charging so that it cannot overcharge this battery pack. And the other is the galvanic oscillations. We will discuss this galvanic oscillation, what kind of this. And you have certain communications also, that serial programmable interface communication, this RS485 CAN, control area network based communication. And certain you also have this certain this real-time operating system, that you have this microcontrollers which can perform this overcharging or discharging protection systems. So let's focus on what kind of systems are actually there inside of this battery pack. If you see, I have given these slides of what kind of what things can be measured inside the battery pack. So you cannot measure the all things. You don't have any sensor for the direct SOC measurement. So you need a certain mechanism to predict this SOC and then calculate it, or for you can use it for the further use. Suppose I am given this cell 1, cell 2, cell 3 and n number of cells. So you have to monitor this voltage level, current level and temperature level. These are the basic measurable quantities, that is a voltage, current and temperature. And you can see after that you have a high voltage contactor. High voltage contactor in what sense? If you connect the large number of batteries in the series, so the voltage will increase. Suppose this voltage of this suppose this is a 12 volt battery, So you can control the n multiplied by the 12. This is the voltage of this whole battery pack. So this high voltage contactor is to prevent this battery pack from this certain kind of damage. So if you see this all data, this is voltage data, current data and temperature data is being sensed by this BMS, and it also take the data from this high voltage contactor also, when to open, when to release this high voltage contactor. If you see in the right side part, the estimation and the prediction part, so you must have a certain model based algorithm to predict the SOC, cell capacity and internal resistance, that is further used for this energy and power calculation. So what the main idea of this slide is that you cannot measure the all things which you have into the your system. You cannot measure this voltage, you cannot measure this SOC, cell capacity or internal resistance directly. So you need the voltage, current and temperature data which is fed to some model based algorithm which predict this SOC, cell capacity and internal resistance for the further calculation of this energy and the power. Okay, that is the whole crux. So if you see this voltage measurement, how to do this voltage measurement inside of this battery pack. So in the right side image I have given one structure of this IC, that is LTC 68021, that is from the Texas Instrument. It measures this 12 lithium ion cells in the series, that is the 12 multiplied by 12 multiplied by 12 multiplied by the voltage which can have this. So 60 volt maximum it can measure. And the stackable architecture, stackable means you can connect this batteries in the series in the stack format. That stack format enables that 1000 volt system. You can measure this 1000 volt system, and the accuracy limit, this error is also 0.25 measure. What is the crux? That is the, if you see this IC, this IC is connected in the parallel, this parallel function of this battery. It measures this voltage, same function as a voltmeter. As a voltmeter, it takes this voltage data, and it also help in balancing also. If you see, there is a multiplexer is there. Multiplexer connect this all ICs into this stack manner, and then further it is used to the A to DC ADC converter, that is delta sigma ADC converter. It takes the battery's data, that in log fashion, and it's sent to this in the digital format to this using the serial data, that is LTC 6801 below. This is a communication block. If you see in the lower portion, that is the one resistor is connected. If you see this 100 kilo ohm and 100 kilo ohm, this NTC is there, negative temperature coefficient, this resistor is there. This is for the protection also. So this is the main how to measure this voltage measurement system, that is using LTC 68021. And if you see this temperature measurement, you have different kinds of systems, such as they using the thermocouple, and you have the thermistors also. Thermistors are such that their resistance is proportional, inversely proportional temperature. If the temperature increases, this resistance decreases for the NTC type of thermistors. And if temperature increases, resistance also increases. This is the positive temperature coefficient resistances. So in the thermocouple, you have a certain hot zone, hot end, and you have a certain voltmeter. Voltmeter, it means that where you have to measure this voltage. This is the open terminal. So there are two metals are there. Suppose there is a copper, and this is a two junctions are there, and the left side they have a different materials. So VDC, that is a VDC, where it can be measured using this temperature difference. That is the basic principle of this thermocouple. That if you have a temperature difference, that is converted in the form of the DC voltage, that is used to measure this this temperature. Okay, so how can you measure? If you make this temperature at this cooling junction at 0, so temperature will be VDC by K. So by that you can measure this temperature. And there is a different methods also, they are using thermistor also. This image, if you see this one IC I have given, this is the circuit 06002 thermistor. If you see, they have a VDD here is there, and two resistors are connected. Two resistors are connected with this op amp. op-amp. This is the basic button. It means that if you calculate this VTH, if the NTC is connected here and this resistance is known, if you wanted to calculate this Thevenin impedance, it means that this is VDD, this parallel of this resistance, and from here that's RTH you can calculate. That is the RTH is equal to R naught e to the power beta 1 by T minus 1 by T naught. Okay, so if you calculate this RTH by measuring this VTH, you can measure this RTH. From that RTH you can measure this temperature. Okay, so what thing you have to do? First you should measure VTH, what is coming across this junction point. Then you can measure this RTH. If you know the RTH, you can calculate the temperature. Okay, this is the basic using of this thermistor. I have given the examples also. If you see this increasing of the temperature, this resistance is going down. This is the NTC kind of thermistor. And same data, if you see this A to D voltage with 100 kilo ohm resistors, that is the measured voltage. That is the measured voltage, and it is fed to some lookup table. Some lookup table have this facility that certain temperature, certain voltage combinations are given. From that lookup table, if you have certain measured voltage, you can measured voltage, you can predict that what kind of temperature is there. That is the main basic functionality of this thermistor based temperature management system. This is the current based measurement systems. I have given the two examples for this purpose. If you can see, there are two things are there. First is the using the Hall effect sensor. Second one is using this current shunt. This is I have taken this Hall effect sensor from the Electro Ohms website, and the right side image taken from the Texas Instrument. So this is a basic functionality. If you pass the current from the center of this Hall sensor, then the magnetic field is created. That magnetic field is used to sense and measure this current which is flowing inside of this battery pack. Same with this resistance, shunt resistance is also there. If you see, this resistance symbol is there. So we connect a shunt resistance across this both terminals, that is a positive and negative terminal. Then we measure this what the voltage is there across it. So the shunt resistance or R shunt you already know. So V is also known. So from that you can calculate that what will be this current which is flowing using this Hall effect sensor or the current sensor. Coming to the next part, that is the high voltage contactor control. So high, what is the basic need of this high voltage contactor control? In the BMS, if you see this, there are certain large amount of sections are there in the EVs. That is the bed. You have a motor also. You have a power electronic converter also to this on and off this motor. You have regenerative braking also. There are different kinds of system are there. So if you see in the left side, this is your battery pack. This is the battery pack. And if you see, there are three circuits are there. This is the main positive terminal and this is the negative terminal. If you observe, this is the positive terminal, this is negative terminal. So we should not operate this should not close this positive terminal and negative terminal at instant. We should follow certain procedure. So why? Because if you see this DC link capacitor, what is the current will be there? IC is equal to C dV by dt. So if you are increasing this directly connecting this whole battery pack, what will happen? C whole battery pack voltage, that is the full voltage, minus 0 because the capacitor voltage is 0, that in a short period of time. So this current will flow in a large amount. So what we will do? We will open these contactors in a series manner, in serial manner. First, we will open this negative contactor. Then we open this P-charge contactor with a resistor in series between them. So this will reduce the current which is flowing through this DC link capacitor. After that, we will open this main positive contactor. If you see this right side image which I have shown you, this main contactor is initially off, made negative current. This is the time frame when it is getting on. First, we will on this negative contactor, then we will on this P charge contactor after some time. Then after finally we will open this maintain this positive contactor when the current reaches to 50 to 60% of the level of the rated current. So this is the main crux of high voltage contactor which is used in this battery pack. And if you see this DC link voltage also, this is initially 0. Then after few seconds it got increases when this pre-charged contactor are being opened. So this reference I have taken from the Texas instrument that a BMS also should take care of this high voltage contactor to control this high transients current also. If you have any doubt, anything related to that, if you have any doubt, you can ask me. Uh, okay, I assume that you are comfortable with the things. So, what we have learned currently, that first BMS, then measurable, what are the measurable quantities inside the battery pack, and estimation and predictor, what can we estimate and what can predict. Then what are the different kinds of methods for the voltage, temperature, current, and contactor control. Then further moving to SOC estimation, last class I have discussed this, but the many of the students always have this doubt. Always have this doubt what is the correct method of measuring this SOC. So this SOC estimation measurement technique I have taken from one famous researcher, that is the Gregory G. Pellet book. That is the this person mainly works on this SOC, SOH, and this BMS kind of system. He is very renowned professor from Texas. So he have given this what kind of correct measurement estimation, SOC estimation technique is there. So in the figure, this figure, if you see, let's take that this is the lithium, this is the graphite lattice. Whole of the structure is graphite lattice. There is a small chemistry involved in it. So if you, there are certain spaces that 1, 2, 3, 4, 5, 6, 7 spaces are there. If the lithium ions comes inside of this graphite lattice, it will form this, it should settle down inside of this lattice, all this 7 lattices. But due to this SCI layer, what we have discussed in the last class, that is the solid electrolyte interface, it not able to percolate inside of this lithium, this graphite lattice. So there are some sections where these graphites get intercalated, but not all the function, all the places. So if you see, there are how many places are there? Total number of places there are 7. So how many they have filled? They have filled only 2. So there is a theta term is there, which measures that how many lattices are being filled and how many actual places were there. And SOC actually defined as theta k minus theta 0% divided by theta 100% minus theta 0%. This is the average term. So theta k means this theta k, what you actually calculated. What is the meaning of theta 0%? It means that no graphite put it into the intercalated inside the graphite layer. It means that it is 0. And 100% means all the 7 got intercalated inside of this. So this is the correct way of measurement of this SOC estimation technique. How you measure that, how many are intercalated? Based on the density, mass and density. So this is calculated that how many lithium ions are got intercalated. That is happen inside of this BMS itself. How this measure this, how many got intercalated based upon this mass density. Here in the right side I have given this image also, that theta is moving from 0% to 100%, If you see, they initially their CS max is very low. This is CS is very zero. After that, it got increases to CS max. It means that theta 100%, it means the SOC is also increasing if the CS is got increased from CS0 to CS max. Okay, this is the one of the SOC estimation methods. If you see this voltage based method, what is the voltage based method? What is the basic definition of this? How this basic structure of this lithium ion cells? See this image, what I am trying. This is the basic model of the battery cells. This is the OCV, that is the open circuit voltage, and you have R0 internal resistance, you have R1 value, R1 resistance are there, then it is connected in parallel with the C1, and finally you have this terminal voltage. So how you can write this terminal voltage? This terminal voltage is OCV minus the current if it's charging IK R0 when it is discharging, IK R0 minus IK multiplied by this whole impedance of this R parallel to C1. This is the basic crux of this basic cell model and its equation of the terminal voltage. So if you see this TINO method is that one of the basic method for calculating this SOC based on this voltage. If you see this VZ means if particular voltage at Z SOC at particular state is equal to OCV ZK minus IK R0. That is the same value which I have written for this terminal voltage. Okay. If you approximate this VK plus IK R0 is nearly equal to OCV ZK because we have neglected this parallel RC term. Okay. So how you calculate the ZK? ZK is OCV inverse of VK plus IK R0. That is basically the TINO method. Okay. Here I have this SOC comparison I have also given. This how you calculate if this is the true SOC which is calculated and the SOC estimated based upon this voltage based technique. So if you see, this is a very vague kind of voltage measure this SOC measurement technique, because if you are at this 50 suppose you have at a 60% SOC level, it measure from this 30 to whole from 80-90% level. So that is not the correct way to measure. Okay, because you need certain error band. No, error band is this is 5% error, 6% error, but the error here is very huge because it is moving from 30% level to above to 80-90% level. So this method generally not used for the correct SOC estimation. This is also one image I have given in the right side. Based upon the temperature versus OCV based in this, Z is the SOC not in percentage, that is the 0.21 means it is 100% SOC level. So it is based upon the different temperature levels. If you see this OCV versus SOC curve, it got increased. Okay, as the SOC increases, the voltage got increased. You have a certain this minimum voltage, then maximum voltage, and in between you have this rated voltage also. Okay, this is the voltage based measurement technique. So moving to this SOH based system, that is the state of health estimation. First you have to study this capacity loss is this image which I have given. If you see here what I have given image, if you see this image, this is the same image what I have told you that this is the lithium ion which got inside of this graphite lattice. So for this SOH estimation, there are certain levels of capacity loss study, that is the level 1, level 2, level 3. Level 1 is such that you first study through the surface of this atomic level, the surface based atomic level. Then you should go into the deep of this intercalated area, And third level of study that you should also take into consideration in between lattices also. In between lattices also. So what will be the study, capacity loss study? First, surface based study, then inside of this atomic level study. Third is lattice, inside lattice based study. So this is the two kinds of loss of capacity methods I have given in the left side of the image. First one is the loss of capacity due to side reaction. If you see, this is the negative electrode from which where the this lithium ion go when the discharging is happening. This is the positive electrode. So if you see, this is when it is moving during the discharging phase, because the current is electron moves opposite direction of this current. So due to the certain side reaction, this lithium ion which are moving from the charging this positive electrode to negative electrode, it did not go completely. Certain lithium ions got trapped due to this side reaction, and it got accumulated inside of this electrolyte itself. So this is the loss of capacity due to side reaction. And in the second process, there is a certain cracking also comes inside of this electrode. So this is a one kinds of loss of capacity due to material loss. So first, how the capacity will be lost? First, due to side reaction. Second, due to the material loss. And how to study that? There are three levels of study. First, study at the surface level, study in between the atomic level, then third level is the between the lattice level. Okay. And how to measure this SOH estimation, that is the capacity fade? There are certain equations. These equations I have taken from one of the research paper, that there is no such concept that you should measure the SOH directly. You should go to the indirect levels. See this equation, this equation 1. This is a SOH at a time t, SOH as a t naught, that is the t naught time, minus this is the overall current which is accumulated over the d tau second, that is from t naught to t, and n is the number of cycles. Why? Because the SOH is inversely proportional to number of cycles. As you go on increasing this number of cycles, okay, this SOH will drop down. State of health reduces after that. And C use is the usable capacity. That n SOC, n means number of cycles, it depend upon this SOC level, rate of charging, TC, that is the TC means terminal voltage, that is the of what the battery pack actually have. That is also upon, this is the capacity, that is 36 multiplied by ampere hour capacity, and which also depend upon this SOC, C rate and TC. And C use the usable capacity. And you can calculate from here the C loss. C loss is, if you see, this linear function of SOC, but exponential function of this C rate and TC. And ampere hour, it is a to the power x type of formula. Okay. So C loss increases as the SOC increases. It also increases when the C rate also increases. When the capacity goes out increasing, if you are using that, C loss capacity will also go on increasing. In right side, I have given two figures. There are certain SOH based measurement techniques. If you see, this is a SOH based measurement technique, that how it is SOC is varying during this time frame. And in the right side, if you see this, how the SOH is increasing with time, that is a saturated and got reduces also. If you see here also, that it is, if initially it was 1, it go on reducing as the number of cycles got increases, that is time got increases or number of cycles got increases. So this is the one of the method for the SOH estimation based on this certain algorithm. Okay. So this is the end of this BMS kind of study. Basic terminology I have given in the form of this, how the capacity loss comes into function, how the SOC got measured and SOH got measured, how the capacity fade happens. So if you before moving to the next slides, I want to ask you that if you have any doubt, feel free to ask me. Otherwise, I should move to the next slide, coming material. Do you have any doubt? Uh, Anybody? Because if you go on searching the lot of slides, no,
No,
lot
lot
of
of
lectures
lectures
will
will
be
be
there,
there,
but
but
you
you
have
have
to
to
go
go
on
on
a
a
specific
specific
manner,
manner.
that
That
at one
at
place you will
one
get this
place you will
current
get current
measurement
measurement
techniques,
technique.
one place you
One
will
place you will
see this
see this
SOC
associate
measurement technique,
measurement
but
technique,
you
but
will not
not
get
get
different things
different
in
things
different
in
place.
different.
So let's move to the next topics. Okay. Okay. Let's move to the further slides. Our further discussion topic will be wide area monitoring system, that is a WAM system. Second is the phasor estimation technique. Second, third will be the digital relay for the smart grid protection. This is for your assignment 4. If you see the questions which are there in the assignment 4, that is mostly related to these topics. So before moving, I have one question for you all. This is question related to wide area monitoring system, and there are certain statements are there. There are 6 statements are there. You have to tell me that which options are correct and which options are false. I will give now certain more number of minutes to solve this question, because last time one doubt was student for there, I'm giving the less amount of time to solve. I'm giving you 3 4 minutes to solve this question. Please go through the question and Dhardi have one question that other than number of cycles which affect SOH. SOH is basically dependent upon this number of cycles. Second, SOC level.
Third,
Third,
temperature.
temperature.
Temperature effect.
Temperature
How you
effect.
see
How
this
you see this
temperature effect
temperature effect
inside of this
inside
R
of this
naught
R
value?
naught value,
Because R
because
naught
R
should
naught
be
should be
measured
measured
for
for
this
this temperature
temperature calculation.
calculation. So
So
if you
if
see
you
the
see the
basic
basic
terms, that
terms, that
SOH
SOH is
dependent
dependent
upon
upon SOC,
SOC,
number of
number of
cycles,
cycles,
temperature.
temperature.
Temperature
Temperature
in
in
what
what
sense?
sense?
R
R
naught.
naught.
Sir, BDF are false. Sir, B BDF
D. Please write it.
false.
D B F
False.
false. Okay. Okay. Any other answers? You have 2 more minutes to solve this question. Read it carefully. Okay.
Any
Any
other
other
answers,
answers,
guys?
guys?
Give the wrong
You can
answer
give
also.
the
There is
wrong answer also. There
no
is
issue with
no
that.
issue with that.
At least you
At
should
least you
try.
should try. If you,
Pratik is
okay, Ritika is
okay.
saying
Ritika is
BDF,
saying
Pratik
BDF.
is saying
Pratik
ACE
is saying
is true.
ACE is true.
Okay, BD
Okay, BD
false.
false.
Okay.
Okay. Yes,
Yes,
Dharni is asking
Dhani
one
is
question
asking one
that does
question
C
that does
rate of
C
the
rate of
battery
the battery
affect
affect
SOH?
SOH?
Yes,
Yes,
that will
that will
affect
affect
SOH.
SOH. If
If
you
you
have a
have a
higher C
higher C
rate,
rate,
it
it
means
means
that
that
you
you
are
are
charging
charging and
and
forcing the
forcing the this
lithium
lithium
ions
ions to
into
intercolate
the
inside the
battery cell. You
lattice.
are
You
forcing
are
that.
forcing that.
If
If
you
you
use
use
certain
certain
atomic
atomic
solutions
solutions
using
using forceful manner, it will create certain effect. The capacity fade, I have given one example. This capacity loss means drawback means reduction of the electrode will happen when the C rate is higher. After that, the electrode loss will be there. Then the SOH means the number of lithium which can intercolate inside of this lithium ion lattices that will reduce. It means that SOH will reduce. And DOD will affect SOH. Yes, I have said that this SOC will affect SOS. SOC is same, you can define this DOD is 1 minus ST. It will also affect depth of discharge because you have a certain limit also that you should not discharge below 20%. You should not overcharge. Also, there will be certain limit. And if you see this lead acid battery which you have in the home also, you should not discharge below 50% also below SOC level. That is also impact this assumption of that lead acid battery which you have in home also. If I use DOT as 80% and DOT of 20% and 100% SOH is same in both cases. If I use DOT as 80% and 100% SOH is same in both cases. No, actually this is if you're saying the SOH, it means that SOH 100%. It means that it is a fresh battery and didn't go into this certain kinds of number of cycles which is being set by OEMs or manufacturer. So if you are using 80%, it means that this SOC level you have maintained at a certain level. But SOH depend upon as you keep on discharging, keep on charging. That will affect the SOH. Okay. Coming to this solution part of this wide area monitoring system, let's read the first statement. First statement said that it is used to monitor and analyze the performance of power system across a large geographical area. That is true. Why true? There are two kinds of system which is given in the module, that is SCADA system and the WAM system. WAM system, from the name itself, it is a wide area monitoring. Wide area monitoring means it goes to the large geographical area using this GPS based system. And SCADA is a localized system operating kind of thing, which is a from a certain part you can use for the SCADA. It means that it is true. It is used to monitor the large geographical area. Okay. Coming to the B part, it primarily focus on monitoring local isolated event within a power system and do not consider border. That is false. False in what sense? If I am saying the first one is correct, it means that it will false in the B section because it will monitor the large kind of geographical area. Coming to C part, it utilizes synchrophasor technology which involves measuring the phasor angle and magnitude of voltage at different points in the power system grid in the real time. That is true. In true, what is sense? Because it uses this synchrophasor based phasor technology based on the GPS technology, and it measures the phase angle and magnitude of the voltage at different location of the power grid in the real time itself. If you have a certain grid if you have a certain kind of this power grid, there are certain regional grids also there, no? If you have a certain bus at Mumbai and you are measuring, you if you want to measure in the Kanpur, then you can measure using this PMUs, this WAM system. You can measure this voltage by sitting in the Mumbai, the bus voltage of this Kanpur. So this is the advantage of this wide area monitoring system. And coming to the D part, that it is only applicable to small scale localized power systems and does not have relevance in the large, that is false. Coming to E part, that is the WAM systems are designed to provide real-time information enabling operators to detect and respond to potential issues, improving the overall reliability and stability. That is true, because it gives the real-time information of the voltage and current data. From that you can detect and you can respond quickly. Okay, for the this is also important for the stability of your power grid. Coming to the next part, that is it is primarily a cyber security measure focused on protecting power system from external threats and attacks on the network. PMUs have certain communication facility. It also has this cyber security resilience also. It has cyber security measurements are also there taken inside of this PMU. That is also that it is not primarily a cyber security measure, but it have a one component of the cyber security measure. So if you are saying that it is primarily, then it will be false. It is not primarily, but it have a certain sections of it. Okay. Coming to this WAMPS applications, you have seen from the question itself, this WAMPS have a certain application in the all this steps of this power system, that is generation, transmission, and distribution. If we see from the generation perspective, this generation operation is status monitoring, transient angle monitoring, that is delta, and this transmission level, if you see the state estimation of the bus bar, this load flow, optimal power flow, load forecast, and economic dispatch. And in distribution, you have a certain kinds of this substation automation, feeder automation, consumer side automation. That is also one of the component of the WAMS application. What kind of substation automation? That's service restoration. Means after the fault, you should respond to that fault quickly, and also make sure that it should come back in a faster manner after the fault. So that is the done through a automation kind of system. That is also one of the application of the WAMPs. Bus voltage control, you can control from a remote location, also from a several distance this bus voltage. Line drop compensation, automatic reclosing, and in the feeders you can also have this automated switching. Feeder voltage also control, this feeder active power reactive power control, maintaining this voltage level and angle level. And you consumer side, what we have the advantage, this advanced metering infrastructure and the automated meter reading, because the WAMPs also allow this bi-directional communications there. No? You should install this PV panels or wind generation based system at your home, then you can feed the power to the grid also. This bi-directional power flow, it also one of the application. Coming to the second question, that is the benefits related to the WAMP system. There are certain four options I have given. You have to tell me that what kind of advantages, this benefits of the WAMPs. Whether the first one is the benefit of the WAMPs, second, third, or all. Please solve this question. Okay. Dharma is saying ACD. Okay. Any other answer? You have 2 minutes to solve this question.
Power system restoration.
Deepa is saying power system restoration, D option. Okay. Any other answers? Okay. Pratik is saying all. Deepa, you can switch off your mic. If, okay, thank you. Okay, I've got the couple of answers, that some is saying AB, some is saying D option, some is saying all. Actually, the all options are correct. Why? Because in the WAMP system, you have the real-time monitoring also. Because I've said that this PMUs have this capacity that there is synchronophasis technology is there. So you should monitor and get the data from a real time. So this is an example benefit of this real-time monitoring. And the post-disturbance analysis are also one, because you have the data centers also there which collects the data in and store in the databases. So post-disturbance analysis can also be done using this WAM system. Adaptive production in the what sense? Adaptive production means if you have a fault at a particular location, so if there is a, you have to clear this fault at a very first moment. After that, you should restore after that this fault will be. So it have this adaptive protection. It should protect this, then it should come back in the restoration function. And in the restoration also, it is a one of the example of this benefit of this VAMPs. So adaptive is also there. It will adopt to this. VAMPs is a one of the benefit that it should adopt to this protection. Adaptive protection is there. In the right side, I have given one example that if there is a power system, whole power system plant, there are certain PMUs are there at a particular locations. So it senses using this CT-PT data, it converts and senses and transmit. How this high speed transmission communications are also there. Then it goes to the VAMPS PAC controller, that is logic processing, army control and decision and alarm. Then it gives this information through this communication channel to the protection elements and control elements. Then it is given to the plant. So you have a closed kind of system from the all the power plant that PMU takes the data, then it transmit to the VAM PAC controller, then it transmitted to the production elements and the control elements. So all are the correct option. Okay. Coming to this components processes of this VAM system, there are certain components of this. First, I have told you this PMUs are there. Second is the phaser data concentrator, because if you are taking the data from the PMUs, you should have a concentrator where this data collected and transmitted. So this fader, this PDCs, the fader data concentrator, help in that concentrating the data and transmit to the further level. And you have a synchrophaser system, that is a GPS based technology for the time synchronization of the all the phasers. And for the you have the communication channel which to the optic cables. This data from this PDCs, you have the set data, it is transferred to this further level for the processing and control. And visualization analysis tools are also there, and wide area situational awareness system through alarm or certain data alarm or any other message based system can be given, and the wide area protection and control, which is the last step. So in the first figure which I have shown you in the left hand side, there are certain PMUs are there which is connected to the WAN system, wide area network, for at a layer 1 where the data acquisition takes place. Then in the layer 2, the data management will be there through this pager data concentrator. Then it is transferred to the data services, that energy management system or application data buffer. If you see the right side first image, right side first row image, there are certain PMU stations are there which is connected to this PMU GPS receiver, and then it is transferred to the communication level where the data is transmitted, then processing is happening at a local level, or local or distributed level. And it also, this super data concentrator is also there, which is an upper node of this data concentrator, because super data means it have the high storage facility which take the all PMU data, okay, get collected. Then PMU1 have a local concentrator, that is a data concentrator at a local level. Then it is connected to further with the super data collector concentrator, SDCs. Okay. Coming to the next slide, this is also related to this PMU benefit. So there are 4 statements I have given. So you have to tell me that which options are correct related to the benefits of this PMUs. Please solve this question. You have a 4-5 minutes to solve this question. Read it carefully.
All.
So all are correct.
Okay. I have got one answer. That is all. Okay. One more answer that all are correct. Any other answers? Any other answer, guys? Take your time to solve. There is no issue. We have a lot of time to discuss and analyze a question. 1 minute left. 1 minute left for the question. Anybody else? Okay. Sigma is saying all. Any other answer? Okay. Anybody else? Ritika, Devin, Navneet? Okay, Shankar is saying correct. Navneet is saying correct. Good.
At least you
At
are
least
giving
you are
the
giving the
answers. That is
answers.
the
That is
most
the most
important thing.
important thing. Thank
Okay.
you very much. Okay. Coming to this benefits of PMUs, this question. Actually, that option are correct. That all are correct. I have made this question regarding to that the slides which you have provided. You have been provided. I have joined the all the columns. If you see the one slide were there, the benefits and further benefit that certain parts were there. I have combined all this in the one state, this four statement. Coming to the first statement, to provide operators with a real-time knowledge of the system conditions, which helps in improving the calculation of the real-time path flow and optimal dispatch and provide actual limit of the system instead of conservative ones from the offline calculation. That is true. Why true? First, we know this real-time monitoring we have, and we have this controlling part also. So if you are measuring this real-time data, you can control the from this VAMS controller system. Coming to the B option, to reconstruct the sequence of event after disturbance has occurred, which makes it easier to understand sequence of event when using the synchronized data. That is true because the all systems through PMUs are being synchronized. So you can get the data from a single place from the all PMUs through SDCs and this is central based distribution concentrator or at a central node also. Coming to the C part, that to adopt a protection which is appropriate with the system condition, which gives improved backup protection and adaptive protection setting to avoid cascading outage. That is also true because if you see the blackout which was happened in 2011-12, uh, at that point also I have told you that that was actually a reason of this cascading outage. This this PMUs give the advantage of that to avoiding this cascading outage. Coming to the fourth part, that to assist system operator during the restoration with data, which gives him more confidence during restoration. That is true, to reduce the chances of recurrence of the system outage and reduce time needed for the system restoration. That is true because if you have a certain mechanism of real-time monitoring and real-time control, then this system operator will be in confidence that he can monitor and he can restore it the system from after coming from the fault itself. So that is the advantages for the system operator as well. Coming to the next question, this question is related to the difference between the PMUs and SCADA system. So you have to tell me that which options are correct related to this PMUs and SCADA difference. We have 4 or 5 minutes to solve this question.
A, B, E false, C, D correct.
C, D are correct, sir.
Okay. First answer I have got that CT is correct. Okay. CD I have got one more answer that CT is correct. And Dharni is saying BCD is correct. Okay, I've got one more answer that BCD is correct.
No, sir. I said C and D.
Okay, let's see which of the anybody else. Ha ha!
Okay,
I've
sir.
got the
Thank
answer
you.
that CD. Two people from CD and one answer from BCD. Yeah. Okay. 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 Pratik is also saying BCD is correct. Shweta is saying it means that I have got two favors for BCD and three favors for CD. Okay. Oh, Dandi changed his answer. It means that four from CD and one from BCD. Okay. Ritika is saying BCD. Okay. Okay. This the people are increasing not defending their answers. They are continuously changing it. Okay. Let's go to the solution part. Uh, this is the basic image what you have taken. You have been given in the slides itself. That this SCADA system and PMUs, they have a totally different functionality and their operation. First is that this resolution, come to the resolution part. This SCADA have a less resolution, that is the one sample every 2 4 second, means one sample per 2 4 seconds. That is they have a less sampling rate. If you come to the PMUs, it have a larger sampling rate, that is the 10 to 60 samples per second, and also it takes a transient and dynamic observability. But in the SCADA, you have a steady state observability will be there. And in the SCADA, you can measure the magnitude only, but in the PMUs, you can measure the both this magnitude and the phasor as well. SCADA don't have any time synchronization, but PMUs have due to the GPS functionality. And the inputs, if you see the input part, it have 100 plus analog and digital IOs. But in the this PMUs, you have a 16 plus digital IOs and 16 plus analog and nearly 10 for the phasers. Okay, 10 phasers. So it have a less IOs, but the complex functionality is there. And if you focus on the focusing areas of this SCADA, it has a local monitoring and control, but the PMUs have wide area monitoring, for which it has been used in the wide area monitoring system. Okay. So coming to the solution part, you have got the solution as well. The PMUs only steady state, that is false. Both SCADA and PMUs have time synchronization, that is false. And coming to SCADA measures only magnitude, but PMUs measure, that is true. Coming to next part, that is SCADA is for local monitoring and control, but PMU is for wide area, that is true. PMUs have more number of digital IO pins, that is false. Okay, CD is correct answer. Okay, coming to the next question, that this question related to digital fault relocate. Okay, it is also one of the application of this WAM system, wide area monitoring system. You have a 6 options. You have to find out that which options are correct. You have a 4 to 5 minutes to solve this question. Yes, Dharni is asking that at present in any real projects we are using WAMs. Actually, WAMs is used for multiple applications. Here, I have seen in the IT Bombay itself that there are certain people are there which works on this wide area monitoring system, and they make certain controller based designs also by taking the data from this last 2011-12 this blackout when happened. So when the system got desynchronized, uh, when the fault come, what were the stability issues? That is a one of the application where they are taking from the databases itself. And in the present situation also that controlling part, because it is a OEM dependent, because you have a power grid there is there, grid India is there. So they do not disclose this data to it. in a public domain, but they work in the this closed community-based research are going on related to this WAM system. You should not get in the public domain most of the data. It is also one of the security issues also there.
ACEF true.
Sir, B and F are false.
Is okay, ACEF. Okay,
B and F are false.
B and F are false. Okay, okay. Any other answers? Ritika is saying ACE is true. Okay. Any any other answers? You have 2 more minutes to solve.
ACEF true.
Read the statements carefully. Okay, ACEF. Okay. One answer I have got that ACEF, and one other answer that BF is false. Okay. Sweta is saying BF is false. Okay. When the two options are there, it says that BF is false. Two persons are there. Ritika is saying ACE is true with this subdomain of one of the person. Okay. Anybody else? Last 10 seconds. Okay, let's go jump to the answer part. Reading the first statement that these are the devices used to record and analyze the electrical waveforms during abnormal conditions such as faults in power system. If you see this part, what are the statements I have given that digital DFR are the devices that used to record and analyze this electrical waveform during the abnormal conditions. What do you mean by this? This is the actually from the statement, this name itself, that digital fault relocator. It will relocate the fault when during this abnormal condition. Okay, abnormal condition. It means that first statement is true. Coming to the B option, that DFRs only capture data during steady state condition because the after fault condition. The fault is a transient, and after during the steady state and do not provide information about transient event in the power system. That is false. Coming to C option, that DFR are using digital technologies to store data in the digital format, allowing for accurate and detailed analysis of the electrical disturbance. That is true. The primary focus of digital fault relocator is to provide real-time monitoring of the power system conditions, helping operators identify potential issues and improve system reliability. That is true. And coming to the E part, that DFRs are commonly used for post-event analysis. That is false. Because the pre condition, that is during also you can use that, allowing engineers to investigate and understand the causes of the power system. This is the way kinds of answer can be given. It is true one of the sense, but it is false of the one of the other sense also. The DFRs are commonly used for post-event analysis. That is true, but it have a certain time duration also, that you can do the real monitoring using this post-event data after learning from it. Because in the first sense, if you see, that it is used for this post-event analysis. But when the fault comes and you have restored the system from that study, you can get the other this fault relocated recorder also, that you have a certain monitoring, real-time monitoring. From this study, you can control the other part when the same situation happen in the system. So this kind of system can be true in one sense, and ambiguity is also there. Coming to the F part, that digital fault locators can only record data from a specific point in the power grid. That is false, because if the fault locator is there, it should measure the other location also. That is not a single point, that is not a single node, limiting their capability to capture and the different location. That is false. So that is B and F is false. That is the correct answer. And here on the right side I have given one image also where there is this client and server and intranet kind of system is there. So in the client system, if you have a circuit breaker and digital fault locator, this data is fed into this analysis for the analysis using these softwares, and then this DFR, this digital fault locator recordings when sent to the this analysis software to this databases to the server itself. Then this server is being can be used through intranet, not internet. Intranet means localized phenomenon. Okay, internet means it is can be accessible to the other systems also. It means localized study can be done. Okay, coming to the next question, that is the sixth question. There is a this waveform is there, one signal, one waveform, this dotted and other is solid line waveform. You have to tell me that what is the phase difference between the both the signals from this data what I have given.
18 degree.
First option is 18 degree, one instant. Okay, any other answers? Take your time to solve.
Sir, 18 degrees.
Okay, two-person are saying 18 degrees. Anybody else? Take your time to solve. There is no issue. Okay, Jitendra is also saying first option. Ritika is also saying first option. Okay, anybody else? Okay,
Yes,
let's
sir.
clarify
Actually,
what they are saying.
time period for
Dharmendra,
one
let's
cycle,
solve
1 by
this question.
50, 20 milliseconds, right? And in 20 milliseconds correspond to 360 degree.
Okay, okay.
So 1 millisecond, 360 by 20, 18 degrees.
Mm-hmm. Okay, that's the correct solution. Okay, you can you can close your mic. Okay, thank you, Dharmendra. Okay, what Dharmendra have told that if you see from 150, this is the frequency of this system is a 150 hertz. So time duration that is 1 by 20, that is 20 millisecond. Okay, so this 20 millisecond, because you have with this Fourier analysis this C 60 degrees, but moving from this time 0 to whole of this time 0 again, the whole time period. So 360, the overall duration is correspond to 20 millisecond. So what will be the 1 millisecond duration? It is 360 by 20. It means that 1 millisecond with the sampling rate is 1 millisecond. It means that it is 18 degree. Okay. So phase difference between these two signals are 18 degree. And one more, there are certain methods also to compute that. There one method is that when the frequency is 1 upon 2 pi, d phi by dt. From here also you can calculate this delta phi, that delta phi is equal to omega multiplied by delta t. This delta t is when you are taking this samples, sample duration from two different sample points. When you are taking this is delta t, and omega is what given, that is 2 pi f. From here also you can calculate this phasor difference. Okay, so coming to this next part, this question is such that using this Nyquist criteria, what I have told in the first lecture itself, that the sampling rate should be greater than or equal to 2 times of massive frequency to avoid aliasing phenomena. Okay, okay. So you, in those question, this FT have three signals. In the summation format, you have to tell me that what will be the minimum sampling frequency in hertz to satisfy this sampling, this Nyquist criteria.
50 hertz.
Okay, I have got one answer as 50 hertz. Anybody else? First answer I have got that 50 hertz. Okay, anybody else? Take your time to solve. No issue in that. Anshuman, Dharni, Deepa. From the Deepa I have got the answer. Ritika, anybody else? Okay, Ritika is given 87.964. Second answer I have got that 87.964. Okay, anybody else? Anybody else? Try this concept of this Nyquist criteria, that Fs is greater than or equal to 2Fm to extract the message signals from the exact values. You should have certain range of sampling so that you can extract the all signals at a time without any loss. Any other answers? Okay, let's come to the solution part. Let's see this solution. What the question is saying, that it have a three component, that three sign component. If you see this, if, this is the one of the signals, second is the other, third is sine 14 pi t. In the first sine part, that is 3 sine 8 pi t, if you want to sample this, so what is the criteria? That Fs is greater than or equal to 2 times of Fm. What is the massive frequency here? Here the massive frequency, because the omega is given, that 2 pi f is equal to 8 pi. It means that frequency is 4 hertz here. Okay. So what will the sampling frequency? It should be greater than 8. Okay. In the second part, that is the 6, 9, 12 pi t, here the frequency, that is the omega is equal to 2 pi f is equal to 12 pi. Here the frequency is 6 Hz, massive frequency. So the sampling frequency should be greater than or equal to this 12 Hz, 2 times of this. Coming to third part, that is the sine 14 pi t. Here the FM will come to 7 Hz. The Fs will be greater than or equal to 14 Hz. So what we have got, the sampling frequency as a 8 Hz critical and 12 Hz and 14 Hz. So now the question is, which sampling rate should I choose so that we should extract this signal completely. So if you choose 8 Hz, then there will be loss in the 12 Hz and the 14 Hz, because here the sampling rates are much higher as compared to this 8. Okay. If you cover this, take the sampling rate that 12 samples per second, then 8 can be extracted from that, but the 14 will be have a problem, because it comes in higher range of sampling frequency. But if you choose the 14 Hz as a critical sampling rate, you can extract the 12 Hz signal completely and also 8 Hz signal completely. So what will be the sampling rate? It will be max of this Fs, so it should be 14 Hz, not 50 Hz, not 87.964. Okay. So this is the basic sampling time, because if you see from this also that if you have a certain triangular signal, suppose one triangular signal, second triangular signal, third triangular signal, so you must have a certain band of this signal. That's to extract the whole signal. Suppose you want to extract these two signals at a time, so you must have a band of this, not this, to extract. So sampling rate, in if you are extracting two, it should be higher. So if you are extracting the all three at a time, so you have a band of higher, sampling rate should be higher. Okay. So coming to this question, this is the next question which you have to solve. Solve this question. This is the related to this anti-aliasing filter. This is a one electronic based question, but it is very important if you have the concept of this RC circuit. Yes. Ritika is saying it is correct that 28 pi should be there, but I have asked in the Hz. So if you say that in omega term, omega s, that should be correct. In the omega s should be 28 pi. That is correct for the 28 pi.
But
But
if you
if
are
you are
saying
saying
in
in
the
the
Hz,
Hz,
this
this
samples
samples
per
per
second,
second,
then
then
it
it
should
should
be
be in,
it
it should
should
be
be
24.
24.
It
That
is
is
true
true
that
that
in
in
the
the
omega
omega
you can
you
say
can say
that
that
it is 2
2 pi
pi
f,
f,
that
that
is
is
the
the
2
pi
pi
multiplied
multiplied
by
by
14,
14,
that
that
is
is
28.
28.
That is correct in
The
the
radian
radian
per
per
second.
second. Solve this question.
Solve this question.
This is also one of
This
the
is
important
also one of
question.
the
I will
important
explain
question.
one of
I
the
will
design
explain one of the
features of
design
also
features of
this
also this
anti-aliasing filter. Ritika is saying 7.95 into 10 to the power minus 8. Okay, R, oh, it means it will be C, I'm guessing. Ritika, it's C or it's R. R should not be at a lower level, so I'm considering it as C. 7.95 into 10 power minus 8. Okay. Okay. What will be the R value? by choosing R is equal to 1. Okay, 1 ohm, 1 kilo ohm unit. You should specify the unit always. It's a farad or it's kilo ohms. Always specify the magnitude 1 ohm. Okay. If you have any doubt in the question, you can ask me. Open your mic and ask. Okay. Ritika is saying frequency is 1 upon 2 pi fr, that is C value. Okay. Yeah, Ritika, I have got your point that you are using this frequency is equal to 1 upon 2 pi RC term. That is fine. Take your time, guys. Take. I'm giving you 2 more minutes to solve this question because it's an important question. The theory part is also important, but the design criteria is also important. Last 1 minute. How you are solving, you can also tell me that. How are approaching this question? Anybody? What is coming in your mind? Sweta is saying 1.97 kilo ohms. Okay. At what C, Sweta? Anybody want to explain that? How he is approaching, how C is approaching? Okay, time's up. Time's up, guys. Let's come to the solution part. First, read the question. Let's read the question. The question is such that considering a continuous signal with a maximum frequency component of 500, it means it is a continuous signal, no sampling is done. So maximum frequency component of 500, that is the F max, masses frequency, maximum masses frequency 500. What it is asking that design a first order RC low pass filter as an LT aliasing filter with a cutoff frequency of 2000. There is certain cutoff frequencies also there for the low pass filter. Suppose this is the low pass filter, this is the basic criteria that, so this, if it is a cutoff frequency, then this filter will pass the frequency which is lower than that, the less than FC. And if it is a greater than frequency, it will provide the low gain. Low gain means it will drop down and not allow to this signal to pass. So it is saying also that you have to design this first order RC. First order RC in what sense? Order means the yes power. The power of yes should be 1. In that fashion, you have to design that. Second order means 1 upon s square plus something term. Okay. First order RC filter given by Fc is equal to 1 upon 2 pi Rc, where Fc is a cutoff frequency, R is the resistance, C is the capacitance, resistance and capacitance. You have to find out that R and C. Here the cutoff frequency is already given at 2000 Hz. You come to this gain and frequency plot which I have shown you. If you see this, Fc is equal to 1 upon 2 pi Rc. How you have solved this? This is the R and this is C. This is the first order RC circuit. How you provide this? This equation will come. Let's take that omega is equal to 0. At omega is equal to 0, this capacitor is open circuited. This capacitor is open circuit. Then the what signal you will apply at input terminal, you will get at the output at without filtering from this capacitor. So the gain is same as V input. Gain is same as the V input. Means V output by V input is if it is a gain, it means that the gain you are giving is 100%. But if you apply this omega is equal to infinity, at omega is equal to infinity, capacitor will be short circuited. Capacitor short circuited, it means that no signal will pass from this V input to V output side, because V output is 0. Means V output by V input, if it is a gain, in this case the V output is 0 by V input, the gain is 0. So it will not allow to pass through this filter. So this is the basic functionality of this RC filter. Okay, you can calculate this what will be the V output by V input ratio. How you will calculate this? V output by V input is equal to 1 upon SC divided by 1 upon SC plus R. It will come out to be 1 upon, if you see this, 1 plus SRC. So 1 upon SRC, what do you mean by this? This means that this taking from this slide itself, that 1 upon 1 plus S, if you compare this j omega RC, compare the real term and the imaginary part magnitude, that is the omega RC is equal to 1, it means the cutoff frequency will be 1 upon 2 pi RC. This whole system has been taken into consideration for designing of this first RC filter circuit. So here the cutoff frequency is already given. Cutoff frequency is what it has been given. It is 2000 Hz. So if you consider this 2000 Hz, this means that RC value will come as 7.96 into 10 power 5 millisecond. If you take this R value as 10 kilowatt, because you cannot take the 1 ohm resistor inside of this circuit, you should have to take more than 1 kilohertz, yeah, or 1.1 kilohertz. You should not always see that 1 ohm resistor had been utilized for this RC filter design. It will always higher. It should always be higher. 1 ohm will, if you see the H is equal to I square RT, it will, the heat loss will be lower, but I square RT will not provide that amount of gain, because R should be higher. If R should be higher, the gain will be much nearly equal to 1. Okay, so you should always take this R into consideration, that it should always be taken as 1 kilo ohm, 0.1 kilo ohm, 100 kilo ohm, या फिर 10 kilo ohm. So from that value, if you are taking the 10 kilohertz system, then capacitor will be calculated from here. It should come out to be 7.96 into 10 power minus 9 farad. So the designing criteria is this: R is 10 kilohertz and this C is also 7.96 into 10 power minus 7. One more point to consider here, that if you go in the market, you cannot find out that 7.96 into 10 power minus 9 farad capacitor. So you have to take the capacitor which is the nearly equal to that. Suppose this is 10 microfarad capacitor is available in the market. So you have to take that 10 microfarad capacitor to come up with the solution of this your problem, because you do not find, manufacturer will not manufacture this 7.96 type of this 10 into 10 power minus 9 farad capacitor. So you have to go to that value which is already available in the market, that is the 10 microfarad, 1 microfarad capacitor, nearly equal to that. Okay, So this is one of the design criteria that you should take that value which is already available in the market, not that any value that is 7.96. You should take that value which is already available in the market. This is the basic question related to this satellite transmission frequency. So you have to tell me that
1 and 2, sir.
which frequency is being used for this transmitting the signal from the satellite. Okay, I have got one answer, that 1 and 2. Anybody else? Okay, Sibna is saying 1 and 2, or Ritika is saying 1. Okay, anybody else? The last question, FM is 500 or 5000? Okay, message frequency here in the last question, what I have told you, the message frequency is 5000. The maximum frequency is 5000 Hz, but the cutoff frequency is 2000 Hz. So you have to design the filter with that cutoff frequency. Maximum frequency you should not give, this message frequency you should not take into consideration for designing. You should always take this cutoff frequency, because you have to make this question problem such that you should pass the frequency which is lower than that, and you should not pass the frequency which is higher than. So you have to, if you are designing for the 500 to not pass, so you have to take the frequency at a cutoff frequency lower than 5000, that is 2000. I think I have given the answer of your question, Nirni. Okay, coming to this question, this is a simple question. This option is first and second are correct, and this is basically there are two frequencies there at which the satellite communication, this signal is being transferred. So first and second options are correct. So coming to the next question, this question is related to the A to D converter, because you have seen this A to D converter and anti-aliasing filter during this system also. So the question is such that the A is an analog signal with a voltage range of -5 to 5 volt. You have to design A to D converter with a resolution of 16 bit, and you have to determine the quantization step. Always take that such that this step will be 2 power n. Okay, this take into consideration for designing this A to D converter. And I will also give you one of the basic equation also, this SNR, which you can use always. I think most of the question will not be able to do. I have deliberately given this question to make you understand about this SNR ratio and A to D converter. I am giving just 2 minutes. If you know the answer, if you don't know this formulas and all, try no in the comment box, so I can directly jump to the solution part. If you are solving, try PS, or you can open your mic and tell me. Okay, Sweta is saying no. Okay. Anybody trying this question? Type yes. So I will give 2-3 minutes to solve this question. Okay. It means that people are not comfortable with this question. Question is such that it is saying that there is an analog signal with a voltage range of -5 to 5 volt, because most of this analog circuits which operate at a low voltage level, that is 5 volt, 12 volt. Okay, I also have one circuit which I am using, that is also of 12 volt and 5 volt operating range, and your laptop charger, this mobile chargers are also of 5 volt. So most of the electronic circuit uses 5 volt for this operation. So first question is such that the quantization step is such that when you are converting from a signal from a continuous domain to a discrete domain, so you provide some samples. Samples in the what sense? You are taking these samples. You are not taking the all data at all particular time frame. You take the only samples of the data and construct a that's the nature of the signal, same nature of the signal. If it is a time domain signal ft, then you convert in the discrete domain by providing t is equal to nts. T is equal to nts, n is the number of that instant, that is the 1, say 3, and ts is the sampling rate, then 1 ts, 2 ts, 3 ts. So here the question is such that this A to D converter has 16-bit resolution. 16-bit resolution in what sense? Suppose if you are converting digital sense, you take the if you have a 2-bit, then 0, 1 you can take. If you have a 2-bit, then you can take 0, 0, 0, 1, 1, 0, 1. It means that 4 logic are possible. So for with a 2-bit, only 2 logics are possible. So if you take the 3 bits, then 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. How many logics are possible? 8 logics are possible. It means that if you take the 1 bit, the resolution, this number of logics are possible at 2. If you take 2, then logics possible are 2 square. If take the 3, the logic possible is 3 square. We can say that if for the n bits, the logic possible is 2 to the power n. Okay, so for this 2 to the power n resolution, means the number of bits, if I select the particular bit, so because if you have a 5 volt system, you have to convert into the two domains, that 5 volt into, if voltage is greater than 5 voltage, then power should on. If less than 5 volt, the power should off. Then there is voltage range of 5 volt, 0 to 5 volt. 0 volt, it means that it should off, 5 volt, it should on. Same with this 4-bit logics, 2-bit logic, that is 4 logics are possible. Then in 5, you should define the 4 systems, 0 to 5, in between labels. So in 0, it will off in bit if the this 5 minus 0 divided by 4, that is 1.25. So if you go above 0, that is 1.5 to level, then certain logic will follow. If you go above that, that is 2.5 level, then certain other logic will possible. So in the same step, the delta V, that is the voltage range which is between this both system, between the both logic, that is 0, 0 to 0, 1, that is actually the delta V. Delta V is the quantization step size. Quantization. So what you have to do? Take the overall voltage, divide it by this resolution, that is 2 to the power n, 2 to the power resolution. So you will get the in between voltage levels. That is actually the delta V. That is the quantization step size. In this question it will come because the voltage is going from minus 5 to 5 volt. The overall voltage range will be 10 volt. So 10 volt divided by 2 to the power 16, it will give the 0.000153 volt. That is the quantization step size. Okay. Any doubt in this quantization step you want to ask? Quantization step is such that if you have a certain 1 bit logic, that is 0, 1, you should define the two level of voltage, that 0 and 5. 0 means you have a 0 logic, means off. You have a 1, it means the 5 volt, it means it should be on. Same with the 2-bit logic, that is the 4 cases will be possible, that is 0, 0, 0, 1, 1, 0, 1, 1. So you should define that 0 to 5 voltage with the 4 quantization step, that the 0, then it will be off, 1.25, then other, that is 0, 1 logic will follow. Above than that, then 1, 0 logic will be applicable, and at 5, that 1, 1 logic should be possible. That is basic concept of this quantization step size. Coming to the second part, that is the signal to noise ratio. That is the one formula is there. formula is such that SNR is equal to approximate formula is there, 6.02 times of resolution plus 1.76, that is 6.02 times of n plus 1.76. If you put the value of n, you should get the SNR ratio in the dB terms. This formula you can use. So we have 16 bit. So by using this formula, that is 6.02 multiplied by 16 plus 1.76, you will get the SNR ratio, that is 97.28 dB. SNR means signal to noise ratio. Signal to noise ratio. Signal is 20 log V output by V input. That is the basically the what you want. Noise means 220 log what is undesired divided by what input you are giving. That is the signal by noise ratio in terms of dB. In terms of dB. Okay? Are you getting my point? If you can convert this noise ratio in terms non-dB terms, what it has been done in this question itself. From that you can give. And the Nyquist frequency, you all know that this sampling frequency will be 2 times of this message frequency. It means that this Nyquist rate, Nyquist frequency, Nyquist rate means time. Nyquist rate is this time, and the frequency, the Nyquist frequency alpha, is half of this sampling rate, means half of this 100 kilowatt, that is 50 kilowatt. That is the solution. Do you have any doubt in this? Anybody? Any question? Have you understand that quantization step size? That is very, very important, because you give the signal, but you don't know at what quantization step you get that logic. Okay. Any doubt? If you have any doubt, you can open your mic and ask. Okay, moving to the other part, that is the current base, this positive sequence current, because it is also one of the important topic of this PMUs, where it measures this fundamental, this positive sequence component for measuring this healthy condition of the signal. So you have to tell me that there is A phase, B phase, C phase current are given. You have to tell me that what will be this positive sequence component of this system, three-phase system. If you have a background of power systems, then you can solve this question. And if you want me to give the formula, you can also ask, write in chat box. I will write the formula for this question. If you need formula for this question. Yes, matrix formula will be there. I am giving this formula matrix format, that I naught, I1, I2 is equal to 1 by 3 times of 1, 1, 1, 1 alpha alpha square, 1 alpha square alpha times of this IA, IB and IC. From here you can say that I1 is equal to 1 by 3 times of IA plus alpha IB plus alpha square times of IC. What is alpha here? Alpha is 1 angle 120 degree, because it is a 360 degree system and you have a 3 phases. So 360 by 3 will be 120. So each phase shift will be 120 degree between the phases. We can use this formula.
Phi angle 30 degree.
Okay, I have got the one answer, that 5 angle 30 degree. Okay, anybody else? I have not solved the question. I don't have the solution also. So I request anyone to give me the solution. I got from Deepa that 5 angle 30 degree. I've given the okay 5 angle 30 degree Pratik also. Okay. Thank you Pratik. Thank you Deepa. Anybody else? Anybody else you who want to go with this answer? Just feed in your calci. You can get the answer. Okay. Dhanni is also saying 1 angle 30 degree. Okay. Cool. Let's jump to this solution part. Okay. What I'm saying that I1 is equal to this formula that 1 by 3 Ia plus alpha Ib plus alpha square Ic. That 1 by 3 times of Ia. Ia means 5 angle 30 degree plus 1 angle 120 degree multiplied by this Ib. Ib is 5 angle minus 90 degree plus Ic 1 angle minus 120 degree alpha square and this 5 angle 150 degree. If you solve this 1 by 3, this 5 will come outside. This 1 angle 30 degree plus 1 angle, this 30 degree plus 5 will here, 5, 1 angle 30 degree, it will come out to be 5 by 3 multiplied by 3 angle 30 degree, 3 cancel out, this 5 angle 30. So 5 angle 30 degree is the correct answer for this I1. Okay. So let's jump to the next question, next topic, that is the file structure. I have deliberately given this slide for make you to understand that when you communicate, when the communication is happening, there is certain set of data sending format. It means that first you send this data, then the receiver part, if you have a transmitter, you have a receiver, then you should have a certain identifier of this signal, and in the receiving end you have certain acknowledgement part also, because this transmitter must have send this information about the from where it is sending, what kind of data is there, how many data is there, and what kind of signal it is want to transmit, and receiver must get this data to acknowledge this to the transmitter that I have got the data and I have received the data in the that format itself what has been sent. So there is a certain data file structure is there. First, if the first file is transmitted, then the first step is sync. Sync means the first word of 2 bit is for the synchronization of the data transfer. Synchronization means it should have synchronized to this receiving end, that what kind of data and what kind identifier is there for this. So this is the MSB and LSB. This 2-bit data will be there for the sync. Then the second word defines the size of the total record. That is suppose it have a 8-bit data. So second bit must acknowledge that this is a 8-bit data, that is frame size. And third word identifies the data originator uniquely, means from where the data originally has been identified, that is the ID code. And in the next step, that is the next 2 word, provide the security of the century, that is the second of century, and the frame of the second, means the rate at which the data is being transferred. And after that this data is there, data 1, data 2, data n certain. Suppose you have a 32-bit and you are sending 4-bit at a time, it means that you have a 4-bit, 4-bit, 4-bit and 4-bit, 16-bit if you want to send, then that kind of frame will be there, data structure. Then finally the check will be there that the data which you want to transmit, it is in a correct sense. How you can acknowledge? Through the parity check. Parity means if you have even number of bits, you should set that 1. If you have a odd number of bits, it means that it is 0. So this kind of system will be parity check for checking this, that you have correctly got the data, suppose it is a 16-bit data, it is a even, it will be acknowledged to 1. And if you got the 15-bit only and one data bit lost, then you should get the 0. It means that the sender, this transmitter, should send this data again to get the 16-bit, means the receiver have not correctly got this transmitted data. So this is the file structure of the synchronophaser standard. Okay. Coming to this next topic, that is the FFT based system, that I have given one question, because the FFT is also very important, the fast Fourier transform, you for the sampling of the signal. I have given one of the question related to that, make you understand that how you should approach this kind of question. So I'm certainly know that you should not have knowledge of this, but I will make you understand about that. Uh, I request you to read this question once. After that, I will solve this question by myself. At least read this question. Okay, I hope that everyone have read the question. Let's come to the solution part. I will make you understand that how you should solve this question. You know that this during the 50, when the transformation is done, that n is equal to 0 to n, that xn e to the power minus j omega n omega, omega n omega naught. Omega naught means this n 2 pi, this 2 pi n by this 2 pi by n, sorry, e to the power this. So what you will understand, this k is n, that if you see this n part, if, and this in the continuous domain, that is the j n omega naught, if you compare this omega naught is 2 pi by t, and in the same with the discrete domain, that omega naught, this 2 pi by n, that is the number of samples per second. So here the frequency, what if you are considering in the this Hertz term, that is the 1 by f, and n will come. So the fundamental frequency you want to calculate, you must see this e to the power n term. From that you will get this number of samples, this f naught, fundamental frequency. That fundamental frequency will be 1 upon n. That is the total number of samples per second, inverse of that. Here in the question, n is equal to 64 is given, means 64 samples per cycle. So f naught will be 1 by 64, that is 0.0156. What do you mean by this? If you are sampling this means 64 samples per second, what do you mean by this? Suppose you have a sinusoidal signal and you want to convert into discrete domain, so you need a certain transformation. Suppose I am taking the FFT transformation from converting this continuous domain to discrete domain. So this FFT transformation have certain equations, means certain how many samples you want in one cycle, what should be the duration of this continuous domain. So if you want to sample it, then we have sampled is suppose at a n samples per second. So it means that for for this t duration, you will get n samples per second. What do you mean by this? It means that the frequency of the signal will be 1 by n. So that is the same between, if you are getting 64 samples per second, it means the frequency will be 1 by 64. It means 0.0156 Hz for sampling this signal. And in the second part, that is the total number of samples, n. This n will be n times of 1 upon fs, because you are transmitting n samples per second. So it means that L is equal to n 64 multiplied by f1 upon fs. 1 upon fs means add a sampling rate. Here the f naught, that is if you are sampling with the 800 Hz, It means that the length of samples will be 64 divided by 1 upon 800, because you are sampling in this question, you are sampling the second part 800 hertz. At this sampling rate, the sampling frequency, you will get the total length as 64 multiplied by 1 upon fs. Suppose in the same question, if you want to calculate the f3, that is the third harmonic component, it means that the third harmonic will be 3 times of this f0 if it exists. The what you got the f0 at 0.0156, that is the same, this is the 3 times of this fundamental, that is come out to be 0.0691. That is the one of the logic, that how to transform this question into this discrete domain, this continuous domain signal to a discrete domain. By calculating this fundamental will be, what will be the fundamental, what will be total number of samples you get, what will be the third harmonic component in that part. So coming to the last question, this is related to the relay operability. You have to tell me that which options are correct. There are certain equations are given in your PPT. This is a only formula based question. You have to tell me that which options are correct. This is the last question for this today's session. Anybody? If you don't know the formula, you can ask me to solve. If you don't know the formula. Okay. Sidna is saying 2 is the correct answer. One person have given this answer. Anybody else? Okay. A option is also said by Shweta that A option is correct. Okay. Okay. Ritika is saying also A. So let's come to the solution part. The option A is correct. How I am saying that, this is a certain formulas there, so related to relay reliability. This can come to your this exam, because it is a simple based formula based question. The relay reliability, relay security, and relay dependability. So coming to the relay reliability, it means that the number of correctly trips, that is 10 times it have it correctly trips, and number of times it is being desired to trip, that is 20 times, plus 3 times it got incorrect, it will come out to be 0.43. And coming to relay security, you can sense that there is a number of correct divided by incorrect. No, if you can solve that, you will get that the number of correct trip, number of incorrect trip, if I'm total number of trips. I think this is the correct formula, and dependability is such that number of correct divided by number of this total number of trips plus this incorrect. This is the relay dependability, that you can see this this formula from, I am also currently not remembering this formula itself. You can see from this booklet itself that what is the correct formula, and option A is correct. Okay, that's it for the today's session. If I'm not currently Sibna, I'm not correctly remembering the formula, you can see from this lecture slides itself. I will provide in the when you come. Any questions? If you want to ask anything, otherwise I have some small stop this session. Thank you so much.
Thank you.
you so much. Okay, that's the end of the today. Good